Well, then we come to our last presentation. I'm going to use only his first name, Eduard, from Esenca in London. His presentation is Fast and Robust Body Measurement Extraction Used in Virtual Try-On Exploration. Please welcome Eduard.
One moment. Hello there. I am Eduard Cojocea. This is my name. I know the J is hard to pronounce for some Latin-speaking countries. Together with Dragoș, Cosmin, and Mihai, we created Esenca. This is our second year here, so today I will present to you what we were up to in the last year. So, as some of you might have heard the last year, Esenca is a technology company which creates AI-based tools and solutions for apparel, workwear, footwear, e-commerce, and medical applications. Our solutions are web-based. No need to download any app. This is very important. They work on any smartphone with a front camera and a connection to the internet. We achieve a 5mm precision. The inference time on the server side is around 1.9 seconds. So this is the actual time which takes the server to calculate the measurements. But for the user, the actual inference time will be between 3 and 10 seconds. This will be depending on the quality of the internet connection. And also we generate accurate 3D models from the segmentation masks that we achieve during the measuring process. We have developed multiple solutions for measuring the human body. Some of them are fully available, like Esenca Easy Body Fit, Esenca Perfect Body Fit, Esenca Tailor Fit, and Esenca Analytics. And some of them are in development, like virtual try-on, footwear, handwear, and health. Here, we have a brief visual of Esenca Easy Body Fit, where a user inserts his weight, height, age, and gender, asks a couple of questions. He answers a couple of questions, sorry, and he will get the preferred the fit size for every SKU on the shop website. Next, we have Esenca Perfect Fit, where besides the data that I talked on the last slide, the user takes two images guided by an AI virtual assistant in order to have the optimal pose and position. We will talk more about this solution in the next slides. Now, it is important to talk about relevant technologies and what solutions there are for computer vision and machine learning tasks involving body measurement. We wanted to make this measuring technology available for everybody in the comfort of their home, so it was important to make it available on the smartphone because everybody has a smartphone nowadays. So we have to rely solely on what every smartphone has, a camera and connection to the internet. So we don't use any sensors like LiDAR or something like this. Pure RGB data. This means that the state-of-the-art regarding image processing and computer vision, it is the most critical for us to achieve our goals. Nowadays, we have powerful modern computer vision techniques which were beyond our wildest dreams like a few years ago. Actually, this year we celebrate 10 years since AlexNet told us this is the way, meaning that convolutional neural networks are the way for computer vision tasks. However, the classic image processing techniques are still valuable as quick and reliable solutions for many tasks, and most importantly, they serve as liaisons between computer vision models in huge pipelines. They are reliable and easy to use, being available in libraries for decades now, And they are very, very fast and require low computational power. Some examples, we have Canny Edge for edge detection. We have Sift and Surf for feature extraction. We have Ransack and Half Transform and others for simple geometric detection. Also, we have morphological operations, which we made heavy use of them, by the way. And now I'm going to tell you, I will reiterate the same joke I said last year, where deep learning models like YOLO are like a sword, and classic image processing is like a knife, okay? So when you want to eat, you use the knife, not the sword. Next, we will get to the, now that we have paid our respects to our ancestors, classic image processing, we will get to one of the most important object detection tasks, which is object detection, meaning that we have to detect multiple objects in an image, localize them, and classify them. The first family of solutions is regional convolutional neural networks, RCNN, which are very good at what they do, but they are slow because they do thousands of iterations over the same image. As a solution to this problem came the YOLO family, which does only one iteration over each image, hence the name, you only look once. This family of models are degrees of magnitude faster than RCNN, but they are slightly less accurate. But for all intents and purposes, they are very good in practice because they are easy to use and easy to customize. Also, we have models like YOLO-R, which achieved amazing progress in the multitask learning by combining implicit and explicit knowledge. Then we have object segmentation, which of course, when you want to do body measurement is critical. And we have models like MobileNet, HRNet, CDCL, which use various techniques in order to achieve object segmentation. Another important computer vision task is key point detection in order to detect various body parts and to allow us to guide the user in the optimal position, in the A shape, for example. And we have the old models like PoseNet and AlphaPose, but also more modern approaches like MediaPipe and UDP Pose. And we will talk about the positioning system a little later. And of course, since this conference is called 3DBODY.TECH, we cannot omit processing and generating 3D objects. And we have, even since 2005, we have a paper showing us how to generate 3D human models with various poses and shapes. And then we have a more modern approach like HSNets, Pixel to Mesh, SDF style GAN, which all generate 3D models of humans and other objects based on various input shape vectors. Now, we will have a brief look at our solutions architecture so we could see how various components communicate with each other. Our web widget is accessed via shop's website, so it's basically a button in the website. The widget sends to the main server the data acquired from the user, like images, height, weight, age, gender, shop name, and so on. Then the main server sends this data to one of the two measuring servers, depending on which solution was implemented on the shop's website. Then the results are sent to the shop's website to be displayed for the user for each SKU, and they are saved in the dashboard and in the database. Now, let's get to the fun part, talking about our solutions and the technology behind them. So, it is very important to reiterate that all Esenca solutions are web-based. So, no app required, no sensor required, you just need a phone, a smartphone. And our solutions work with any browser, virtual any browser. There are some browsers who do not allow us to connect to the camera, so no camera, no measurement. The data that we extract, like RGB, accelerometer, and gyroscope data, we extract them in order to improve the user experience and to have all the data we require for the correct measurement. Here we have some GIFs that we showed you last year, so don't take them as the current version. They were not too shabby for a fresh startup, but we know that we could improve this UI and UX. So here we have the new version, which is more user-friendly and straightforward. You just input the data. Then you have a very small tutorial telling you how you should have the environment and how you should measure yourself. And then the measuring process, the positioning process starts. Here we have a side-by-side comparison between the old and the current positioning system. Where the old positioning system worked at 6 to 8 FPS, this is referring to the key point detection model. And you can see that the circles in the left are moving much slower than the circles on the right. We did this by changing our key point detection model from a one which runs on the server to a one which runs embedded on the device. So now we achieve 24 to 26 FPS, and we also put the skeleton as an overlay for good measure, so people would understand that the circles are corresponding to various key points of their body, like the head, hands, and feet. Here we have some intermediary processing. So basically, these are snapshots in our pipeline where we have the RGB input data. Then we have a mono image depth estimation. This is very important, so people don't think we have LiDARs or stuff. We have a mono depth estimation, so we basically have relative depth distances, but this helps us to remove objects from the background. Then we do the segmentation, and we extract the mask, which we use for getting the measurements. Here we have the same thing for the side photo. And now during the segmentation process, we have multiple models which help us with solving some problems. We detect various body parts and check if they are not deforming the mask. For example, on the side image, if the hand is not positioned correctly on the hip and it's slightly forward or backward, it will deform the segmentation mask at the hip level. Also, we do skin detection, light estimation, and other such tasks in order to remove anomalies and false detections from the frame. Also, we use a human shape likelihood estimation in order to check various mask body anomalies. So after going through all these models, we get a fine granularity segmentation. The final goal was to measure the body. So the measurements are based on linear distances at various levels on the two masks. Then we process these values using a voting system with multiple custom-made models in order to estimate both volumetric and linear measurements. We also have a fit predictor, which tells us the normal range for various measurements for the height, age, weight, and the gender introduced. So if we get anomalous measurements, we will exclude them, since which will mean that it was a problem either with the segmentation or the user was wearing very bulky clothes or a backpack on the back or so on. Now, we are very excited to show you the new stuff besides improving the model, the new stuff we worked on in the last year. And of course, I'm talking about 3D and virtual try-on. In order to be able to generate 3D models, we collected some available 3D data, and we bought other data. And we collected around 20,000 3D models with measurements attached. And based on these data sets, we trained the model to extract a vector of body shape parameters, which describe the shape of a body. And then, based on these body shape parameters, we trained another model to create the 3D model. You can think about of an autoencoder. You have body, encoding, then another body. And here is the general idea. We have the two segmentation masks that I was talking about. And then you have the 3D model resulted from the two segmentation masks. I'm the guy in the segmentation. You can see I'm a big guy, and this can be seen also in the 3D model. The accuracy of the 3D models varies wildly depending on many hyperparameters, but what we found empirically is that the most important factors are the model optimizer and the number of body shape parameters. And counterintuitive, more body shape parameters does not mean necessarily better 3D models. And here we have 6 3D models generated with the same optimizer but with different number of parameters. The first three are the closest to the ground truth. And we can see the last two, which have 15 and 20 parameters, have significant different body shape, and also they have artifacts. So this is something similar to how a Fourier transform untangles a signal to specific frequencies. These parameters are similar to those frequencies in the Fourier transform. We still have to investigate to see which are optimal. We found empirically that 9, 10, 11 is the best case for now. Regarding virtual try-on, we did a lot of research and development by generating, rigging, and fitting clothes on 3D models. We can generate clothes either from pre-existing objects and deform them, or generate them from scratch. And also, we did some research regarding clothing physics and how this affects fitting. Here is a very brief sneak peek about what we did. It is not yet ready to be shown as a viable solution, but in the next few months we will finish this virtual try-on, and it will be available online. Now let's talk a little bit about the dashboard. So Esenca Analytics is a dashboard where all the data measurements are displayed in the form of customizable reports. As we all know, dashboards run our lives today. Also in the dashboard, all measurements can be visualized on a 3D model by the user. Here we have the measurements of our colleague Cosmin, and on the right we have the avatar, the 3D model. And when the user clicks Open Avatar Viewer, it shows the avatar and the measurements with their exact location of where they have been taken. And this is very useful for tailors in particular to see where we took the measurements, so they have enough information to create the best fit for the clothes. Now let's talk about the results. The same as last year, we collected historical measurements side by side with the ground truth. So we consistently have a smaller than 0.5 centimeters error. Of course, if the user respects the tutorial and wears tight clothes and so on. And here we have the percentages of less than 0.5 centimeters error and less than 1 centimeter error. And also, we did a benchmark with every possible competitor we found online, which was available to freely test it. And some of them, the best 4 are here. We measured all of our colleagues. Here is one of the colleagues. And some of them were very accurate for some measurements, but not for all. Usually, in our experience, some of the major measurements were kind of wrong, like a few centimeters. While in our testing, we consistently achieved 0.5 centimeters in the optimal conditions. One of the biggest advantages is that we have a virtual assistant, which makes sure that the user is in the right position and in the right pose. The user is guided with visual and audio cues, and most competitors don't have such an assistant. They just assume that the user follows the instructions properly. We all know that we tend to not follow tutorials and not listen to explanations. So we had to make sure that the user actually did what it was required from him. Another advantage is the very low inference time. As you can see, we have 1.9 seconds inference time on the server, as I told you earlier, but the user will experience a few seconds inference time, 3 to 10, depending on the internet quality. Now, let's go to the conclusions. So, Esenca extracts more than 100 measurements, only from 2 images, the weight, height, age, and gender, and we achieve 0.5 centimeters precision. It is easy to scale since it is a web-based widget. It is easy to scale for anything you want to do. The measuring engine, it is also easy to scale to adjacent tasks like footwear, handwear, and so on, prosthetics. Also, we have a Shopify app available, so whoever has a Shopify website, just click and they have the button on the website. The virtual assistant, which I have to reiterate, it is very important for us. we got very good feedback regarding the user experience because we have a virtual assistant who clearly states, come closer to the phone, move away from the phone, raise your hands, lower your hands, and so on. So it is very clear on the instructions. And also, we generate the 3D model, and I have to mention here, I don't think I said, we don't have a model which we deform. We actually generate the model from scratch, like a gun, but it's not a gun because generative adversarial network, because this is a more simple task than guns do, because it's a model with no features, it's just the 3D model. As future work, we will implement generative robust virtual try-on experience, where the clothes will automatically be generated, and we will have physics, and so the user could look in a mirror and the 3D model will mimic its pose, so it could see how the clothes fit in various poses. And also we will improve the Esenca Easy Fit, the one with no images, by studying more the body types in the human race, and also to see what were the best questions to ask the user regarding their belly shape or so on, in order to not annoy him, to extract the most amount of info with the least amount of questions. Here we have the team which made Esenca possible, and thank you. If you have any questions.
Yeah, thank you very much. Very impressive presentation with a lot of detailed information. I'm pretty sure there are a lot of questions. Go ahead.
Yes, thanks for the nice talk. I actually have 2 questions.
Yes.
So first, in the demo, you were wearing some very large clothes. Is this a problem, or is there some robustness against?
Yeah, clothing, it is a factor in how well the measurements are done. So the tighter the clothes, the better the measurements. In the tutorial, we say that you have to wear tight clothes, like those gym clothes which are fitted on your body. Those are the optimal conditions. But you could measure yourself in larger clothes, and we'll have to take the larger error for measurement.
Okay, thanks. Second question is related to the measurements. Can you tell us a bit how this is done? Is it probably you will take some joints of the skeleton and then maybe go, I don't know, some fixed percentage up and down, or is it more sophisticated?
Okay, so it is a longer discussion here, but for doing the measurements, we take into account this. The segmentation masks, which are the basis on which we draw the lines. So basically, we draw some lines on the 2D segmentation masks. And then we have some joint detection, and we don't have like a percentage, we have a model trained to detect the exact area, and then we take these linear measurements and transform them into volumetric, like circumferences and so on. So we had, I don't know, tens of thousands of images with actual measurements, and we trained the model to do this, because the first version was based on an ellipse model, which was okay, but not as accurate as we would like. So yeah, it's a longer discussion, but basically we have a machine learning model to do this.
Yeah, thanks. So it's quite sophisticated.
Hello.
Hello.
Thank you for the presentation. I think in the last table, you showed us a comparison between Esenca and other 4 competitors.
Yes.
The last line was talking about the ground truth.
Yes.
Can you tell us how those measurements came?
Okay. So Dragos, our CEO, has a lot of experience in tailoring, so he has the expertise necessary to do the measurement with the tape. So in order to not influence our results, we measured ourselves with the tape first. We wrote the ground truth, and then a few minutes later, we measured ourselves with multiple apps and with Esenca. I know that measuring tape has some subjective value to it, but since we did it beforehand, we removed as much as possible from it.
And another question. You mentioned that one of the future work is going to be the virtual try-on.
Yes.
You showed us the avatar first naked and then dressed with several outfits.
Yes.
Are these outfits going to be generated by 2D pattern that you're going to have in your database, or how are these clothes going to be constructed virtually?
Actually, this is the problem which we thought about. As I said, you could generate clothes from images like we do the 3D model, but for clothes it's a little more complicated because there are more types of clothes, so you have to do a model for each one of them. But you could also have a 3D model of the clothes and just deform them because they are more less susceptible to errors if you deform them. So this is a question we will have to answer in the next few months, but I think the one with the images will be the way to go. So a shop could send us an image with the shirt and we will generate the 3D model. So
A 2D image?
Yeah. This is a problem we need to solve. That's why we said virtual try-on is still in R&D.
Thank you so much.
Okay. Any more? Any more questions? Yeah, over there.
Thank you for the presentation. How flexible is the body shape descriptor for the avatar? So can you also handle asymmetries, for example?
We didn't do a lot of research regarding asymmetries because we wanted to do a 3D model which reflected your measurements and not necessarily your features. And if the asymmetries are not significant, this is not a problem. So we basically said, okay, let's solve the 90% problem, and then we will go to more edge cases. So we don't solve this yet, but we thought about this problem, and we said, okay, when we will have the time to do this, we will do this as well.
Okay. Any more question? Yeah.
I missed the start of your presentation, so apologies for that. But you referred to training data sets. What were the sources of your training data sets?
Okay, so for training data sets, we did a combination of, I said about the data sets we use for 3D models. But for measurements, we had data sets which we collected personally by going to the seaside and taking photos of people who agreed to it, of course. So we had like a booth and asked people politely to help us in research. We collect open source data from online and also bought some data sets. So we have like a hodgepodge collection of data sets which we standardize them as well as we could. This is true both for measuring and for 3D models.
How many subjects are we talking about?
For measuring, it's in the hundreds of thousands of people with measurements. And for the 3D models, 20,000, something like that. We also have synthetic data generated by us, but we do not know how reliable it is. We generated it in order to do the classical computer vision stuff where you do train on synthetic data and then fine-tune on real data. But it was not that reliable, so we still have to work on the synthetic data.
Just to clarify, the subjects were from 3D body scanning?
For measuring, not necessarily. For the measuring process. So
for the training data set.
Yeah. When we have two tasks: measuring the human body and generating a 3D model. For the 3D model, we have 20,000 3D objects of real persons, and for the measuring, we have hundreds of thousands of images and measurements attached to the images.
Okay, thank you.
Okay, thank you very much,
Thank you,
Eduard, for your presentation. And then I'm happy to announce an early conclusion of the last session today. Nicola allowed me to tell everybody bar is open, so please help yourself. Thank you.
Think of all the things, what you're doing, and in my head I paint a picture.